Hello student, welcome all of you on our YouTube channel. This is a lecture for B.Sc. first year student. Paper is Differential Calculus, paper first and semester first. This is our 6th lecture. In previous lecture, we have already discussed some examples how to find the differential coefficient, derivative of the function according to the definition of derivative. So in that case, we discuss some notation like this. If y is equal to f of x be the any function, then its derivative is f dash of x. This is our notation. So f dash of x means first derivative of the function. So here we are going to discuss some another notation. Another notation for the derivative. So in this notation, the changes in the variable x and y denoted by the composite symbols delta x, delta y respectively. Suppose this is a function f from the set A to B, and these are the all values in the x and these are all values in the y. Then the changes in x, we represent it by delta x. So in previous, instead of delta x, there was x, there was h, and there is also changes, that is y plus delta y. So delta y be the change in y. And so that this delta y can be represented as f of x plus delta x minus f of x. So in previous definition, we know that limit h tends to 0, f of x plus h minus f of x divided by h. This is our definition of derivative, and we represented it by f dash of x. Actually, what is this? This is the difference, f of x plus h minus f of x in codomain, in the value of codomain. If this is a x, then there is a f of x, and if this is a x plus delta x, then there is change in y delta y, and there is f of x plus delta x. So in this way, so this is nothing but the change in codomain, that is y and delta y, change delta y. So this delta y can be represented as f of x plus delta x minus f of x. Thus the derivative, so this derivative we can represent in another way, that is limit delta x tends to 0 and change in delta y divided by delta x. That is change in y with respect to change in x. So limit delta x tends to 0. In previous definition, there is a x minus h tends to 0. So here we use delta x and delta y divided by delta x. And we write it as dy by dx is equal to limit f of x plus delta x minus f of x divided by delta x as delta x tends to 0. So this is a new notation. This is a new notation for differentiation, and this notation proposed by Gauss. So dy by dx can be written as limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. Again, in previous lecture we have discussed that how to find the derivative of the function at that particular point, and we was written there f dash of x, if f dash of x is the general derivative, then derivative at the point c is f dash of c. So similarly here dy by dx at x is equal to c means derivative of the function at the point x is equal to c. And then we can use this definition delta x tends to 0 f of x plus delta x minus f of x and divided by delta x. So in this way we can find derivative. Actually our main purpose is that how to write the derivative in another form, and that form is this form. Remember this? I give one exercise to you. By using the definition of derivative, first definition of derivative, you try to solve this problem. Example, find dy by dx. Find dy by dx at x is equal to 0 when y is equal to 2x divided by x square plus 1. You use this definition. Solution, dy by dx is nothing but limit delta x tends to 0 f of x plus delta x minus f of x and divided by delta x. So this is f of x. Y is nothing but f of x. So put value of f of x, then value of f of x plus delta x, and take limit as delta x tends to 0. And after that, when we get dy by dx, then find the value of that dy by dx at x is equal to 0. Now we try this problem. No problem. F of x plus delta x. So what is f of x plus delta x? So 2 into x plus delta x divided by x plus delta x square plus 1. Now what is the f of x? F of x is 2x divided by x square plus 1. So by using definition, dy by dx is equal to limit delta x tends to 0 f of x plus delta x. What is that? This x plus delta x. So 2 times x plus delta x divided by x plus delta x square plus 1 minus 2x divided by x square plus 1, after that divided by delta x. You try to solve this. Try to solve this. You should get some value and then check that at x is equal to 0. There is only cross multiplication and some 6th standard, 7th standards calculation is there. Nothing is complicated. So student, you try this problem and find dy by dx at x is equal to 0. So in next lecture we will discuss an important theorem, very important theorem, that is every finitely derivable function is a continuous. So today we stop. Thank you very much.